Bonjour. Hello, everyone. I forgot. I moved my setup and now my microphone is on this side. I need to remember that. I hope to get used to it. Alright, first off, also need to move this fan away from me now. I moved stuff around a little bit in this room. Well, on this desk, really. Let's see how that works out. And I'm hoping I set up my microphone correctly. Looks like I did. Think I did. Anyway, hello everyone. I am so not used to this setup. I am actually so out of my element right now. I moved my main screen to the left and my secondary screen to the right, which, by the way, should be very, very helpful for some applications that don't... I think it's mostly an X11 thing. X11 doesn't care which one is your primary monitor. It just puts applications at the beginning of the screen, which is whichever monitor you have, leftmost monitor that you have. That was very annoying. Sometimes the applications would open on the wrong monitor, in my secondary monitor, because that was on the left. Now it's on the right, and my primary monitor is on the left. So let's see how that works out. Although it does mean that I would cover Jester, but he's not here, so no big deal. Also, he just sleeps all day, so who cares? We lost view of the mascot dog. Well, he's too good to hang out with us. He's too good to hang out with us. Motherfucker. I don't know where he is, actually. I'm very surprised. I've been in this room for like an hour-ish, and he's not here. He hasn't come at all. Maybe he is too good. I don't know. I am so not used to the setup, oh my god. It's so weird. I keep instinctively wanting to look over here. Hello, Dulce, Peter, and Blurry Squire, by the way. How's everyone doing today? Today's finally the day that I add scripting to my terminal. This time for real, because yesterday I had to add a shell to my text editor, because I'm using that as a terminal, by the way. Emacs is so over. Emacs is so over. So yeah, my text editor now has a shell. And we're going to be adding scripting to that shell. Which, by the way, means I'm going to be adding scripting to my terminal. Well, technically, I'm going to be adding it to both terminals. The old version of the terminal that's currently in the operating system, and the new terminal that is going to be based off of the same code base as my text editor. That's going to get it for... The old one is going to get it for free, because they both use the same shell. And the shell is the one that gets scripted, not the terminal. So that is nice. Also, the way that I designed the shell can allow you to run built-in commands, which means it should also be possible to script other things. My game engine is one of them. I want to make the game engine also scriptable. Is there anything else? Well, the operating system, obviously. If the shell for the operating system is scriptable, that makes the operating system scriptable. So terminal, text editor, and game engine can all very easily get scripting capabilities thanks to this. So that's the plan for today. Yesterday, I spent too much time actually adding the shell to the text editor to be able to do that. And mind you, when I say text editor and terminal are getting a shell, I am meaning the old terminal as well, like the one that's just a terminal. Also the one that is a text editor and a terminal. But I technically mean also the terminal, the text editor itself is going to be scriptable through the same language, the same, obviously different set of like functions that you can run on it, but it is going to be scriptable through the same language as the shell, as the operating system, pretty much. Do you know that Intel chips have Minix in them for... What is Minix? Yo, what? Ah! Why was it... Oh, it's incognito, okay. Mini Unix. Really? And it's in Intel chips? Supported platforms? Okay. All Intel chipsets post 2015 are running Minix 3 internally as the software component of the Intel Management Engine, which is an autonomous subsystem that has been incorporated in virtually all of Intel's processor chipsets since 2008. Wait, is this the one that people were coming up with conspiracy theories of like every computer has a backdoor because of Intel? It was like something for Intel. Is this the one? Was it the Intel Management Engine? I have a slight feeling that it was that. Boy, do I love hearing tech opinions from TikTok. Very, very well-informed people on there. Yeah. Although I do remember hearing it on Twitter as well. Very smart people on there, just all together. I think this is the thing. I think this is the one. Intel anti-theft technology. That used to be a thing? The latest mini kernel is apparently self-healing, which means it never crashes. Whoa! I am new to KDE, but I'm learning new things about KDE every day. Because, like, literally yesterday I learned how to do this. To scroll between windows with the scroll wheel. And today I'm learning about this. Which doesn't work anymore. There we go. Is it every corner or just that one corner? Okay. Wait, I never learned about that before. Because going to the left corner would just take me to the other monitor before. That's why I never knew that. That's why I never knew that. Damn. Okay. I mean, it makes sense that don't most processors have some sort of like fully autonomous system? It makes sense that it would have a sort of mini kernel type of thing. The question is, what happens if that crashes though? Like the Intel Management Engine. Obviously, yeah, self-healing supposedly never crashes, okay. But what if it did crash? Like the old one? What would happen then? Uh, wait, that's very interesting. Minix 1 has 12,000 lines of code. Minix 2 has 23, and Minix 3 has 100,000. Which technically means mine is smaller than that. $60,000. Lines of code don't mean anything. By any means, they don't mean absolutely anything. But it is interesting to know that. It is an interesting thing to consider. In terms of lines of code, it is smaller than a mini Unix. And has more features, probably. Wait, I have seen this icon before. Running X11 with the TWM window manager. Look at that. Damn. Isn't it beautiful? Initial release 1987. Makes it like a little... Oh, abandoned. Interesting. Makes it a little bit older than Linux then, by like 5 years or so. This is one of the best open source project websites I've seen in a while. It looks like it was made last decade, but at least it looks like it wasn't made this century, so that's something. That's pretty nice. That's always a welcome thing, I feel like. Get a master's degree in computer security at the university where Mini X3 was written. VU University in Amsterdam. No thanks. I'm good. Alright. That's interesting. I'd heard of it before, but I wasn't sure even what it was. Okay, I don't know what it is about streaming because I've literally been sitting here for an hour and I've been fine, but the second I press start streaming, it just gets unbearably hot in here. Even with the light on, like that's not the thing. Anyway, might be because it's summer and global warming and Madrid, pretty much. That's the reason. But I checked the weather and apparently today it is colder in the afternoon than the evening. So I'm gonna be streaming now. There was a big debate between Tenenbaum and Torvalds. Tenenbaum also worked on a distributed OS, never went anywhere. Wait! No, I know about that. I know about that. I know about that debate. I've heard of that. Okay, I see that I missed an N, but why did it not autocomplete at all? He looks like my operating systems professor, by the way. A written debate over the internet regarding the Linux kernel and kernel architecture in general. Started in 1992. That I didn't know. I did not know that. Because Linux started in 1991, right? Yeah, 1991. So this was like immediately after it started. This guy just started beef with... just started beefing with everybody he could. I respect that. I respect that. The debate opened on January 29th, 1992, when Tannenbaum first proposed his criticism of the Linux kernel to Comp OS Mini X, noting how the monolithic design was detrimental to its abilities. Didn't it list it as monolithic as well for Mini X? Whatever, man. Whatever. I do remember this debate. Literally, a debate so important that it has its own Wikipedia page. Like, that's enough. Or a flame war, apparently. Anyway. I have like 6 PCs in my room, but it's no match for American air conditioning. Yeah. My building's like 50 centuries old, so... not super easy to get air conditioning. I have to say though, in Spain, we tend to have okay air conditioning. Stores tend to have it. The subway used to have it back when it was managed by decent people. It used to have AC. Now it kind of doesn't anymore. Public transport in general, but it used to have AC. Back in my day, it used to have AC. A lot of homes have AC. It's more of a Northern European thing where, you know, until recently they didn't really need it. I wonder what happened. Why is France constantly nearing 40 degrees nowadays? Wonder why. We did contribute to the Amoeba project back then. Nice. I have heard of Amoeba. I did hear that it kind of went nowhere. We'll see if my whole distributed thing goes somewhere, because I've been meaning to make my operating system distributed, but only now have the pieces come together to begin working on that properly. But we're not doing that today. All right, today we're doing terminal scripting. And here's the thing about terminal scripting. We're going to be using the best interpreted language in the history of programming, Lisp. Which coincidentally, this is Lisp, but that has nothing to do with it. I was just adding the ability to recompile libraries using make to my build system. Because yesterday I kept making changes to my library that I'm using for the code editor, and then not seeing the changes reflected because I'm not recompiling it. So I'm adding that, which my old build system used to have, but I hadn't added it to this. It was literally so easy. Again, this is why Lisp is so fucking wonderful. Lisp is so great. Literally sat down for like 10 minutes and I was like, wait, I need to add the ability to recompile projects with make. All right. Let's go here. Is it not called defun? Did I make it a macro? I think I made it a macro. Yeah, for some reason I made it a macro. Oh well. Oh yeah, so I can use args. Literally so simple. Just called run program with make. C to specify the directory that you're going to be making in. Specify that. And then arguments. So I can put as many arguments as I want in here. So beautiful, so simple. So simple. My God. It's so simple. Lisp is great. Lisp is wonderful. All right, let's talk about how great Lisp is. Because that is the language that I'm going to be using. So I'm going to be talking about Lisp for a second or two, or a minute, or an hour, or a day. Also because I finished my Lisp interpreter. And that happened off screen. So probably the first thing you notice about Lisp as somebody who doesn't know it, and trust me, I have a month of experience in Lisp, so I know what I'm talking about. But the first thing that you notice in Lisp is the parentheses, and they look kind of crazy, and you're like, there's so many parentheses. But if you look at C, like your average C code base is also going to have a lot of brackets, a lot of parentheses, a lot of square brackets. Main difference here is that Lisp uses the same punctuation, the same symbol for all of those things. They're all just one thing. Whereas C uses 3 different symbols for 3 different concepts, Lisp just uses one. So when you look at the parentheses like that, Lisp becomes a lot more reasonable, I would say. Then, right, so I built a Lisp interpreter based off of the Lisp 1.5. And probably the second thing you notice about Lisp is the weird syntax. Whereas we would be used to doing, like, this is Fibonacci sequence, by the way. We would be used to doing something like this. Get the 6th number in a Fibonacci sequence. In Lisp, we would do something like this. And this is Lisp 1.5. It's kind of limited in the way that it works. I don't think it even has officially, like, defines. Like, you can't really define a function. You can, but not really. That's what label is doing, but it's not really a function definition. I will add that, but I don't have it yet because I wanted to have a proper Lisp 1.5 based off the 1.5 manual. But anyway, the way that Lisp works, like with this stuff, is very, very simple. Again, it's the same as before, just the parentheses goes there instead of here. But really, parentheses, these are S expressions, and the first element of the S expression is the thing that you're going to be doing, the operation that you're going to be doing, right? In this case, we're going to be calling the fib function, which is for Fibonacci. And everything after that is just arguments for it. That simple. There is actually a form of writing. By the way, my Lisp tokenizer is actually my C tokenizer. I'm going to rewrite it, but I haven't yet. So it just, these are the comments that I have to use. I have to use C comments in Lisp, which is incredibly cursed. I also am very limited in the kinds of like identifiers that I can use. I can only use C identifiers. I'll fix that eventually, but yeah, it's very cursed right now. I even added a semicolon, which is how you actually do comments in Lisp, so that I could make it look less cursed, but it still looks very, very weird. But anyway, the Lisp interpreter like itself, I was looking at it earlier. It has 300 lines. Literally 326 lines for the entire length. Well, okay. There's a few things outside of that, like the tokenizer, parser, and a little bit of stuff to actually put the stuff together into expressions that the interpreter can understand. But the actual interpreter is 300 lines. And even then, it's 300 lines of C. So there is a little bit of boilerplate. The interpreter it's actually so simple. I think I can explain how it works fully. It works with eval and apply, which, by the way, Jester's not here, so wait, it's gonna cover me now. Fuck. Is that symbol? But yeah, unfortunately, I moved my setup. Now I'm over here, and I'm pretty sure OBS, for some reason, doesn't allow me to move stuff around visually anymore. I have to do it through like a menu, and it's really annoying. So I don't want to move this over here. But yeah, imagine that was over here. And eval and apply are the fundamental functions of Lisp. Literally those two, and then a bunch of helper functions. That's the entirety of it. Eval is going to take an expression and evaluate it. And apply is going to apply an expression. Okay, obviously. That's very reductive. But yeah, eval is just the actual function that is in charge of doing the evaluation of an expression in Lisp. Apply is the one that takes usually a function call and takes the arguments that are being called, takes the arguments of the function, puts them together, and then just puts everything everything together, and then defers to apply to actually evaluate. No, not to apply. Defers to eval to actually evaluate the function. Right. So yeah, apply applies a function to be evaluated, or applies parameters to a function, then evaluates it. Eval is doing the actual evaluation. Right, so even then, the code is very simple, and these here are M expressions, which is something that used to be a thing when Lisp, I was going to say when Emacs, when Lisp was first defined. The idea was that you would write code in M expressions, and they would be translated into S expressions, which are these ones. But people liked S expressions enough that they've stuck around, and this is no longer used. But the Lisp 1.5 manual actually does use them. And they look a lot closer to C code. Like, this is the eval M expression, and this is the C code for it. Like, if you look at just the signature, eval EA, eval expression, and I don't know what A stands for, to be honest, but it's an environment, right? Variables and whatnot. So I called it env in mine, not A. But yeah, very similar. Just using square brackets instead of parentheses. And using semicolons instead of commas. But it's very similar to a function definition. Or a function call. This atom E is this. Is atom expression. This here is an if. So it's a pretty simple function, and also M expressions are pretty simple to understand. But essentially, eval is going to take the expression that it's going to evaluate, and if the expression is atomic, so the opposite of being a list, obviously Lisp is the list processor, so everything is considered to be a list. But if my expression is this, add 1, 2, why is the indentation being weird? Why are you being weird? Just stop doing that. God. This here is considered to be a list, whereas each individual element of that is considered to be atomic, in that you can't break it down into further sub-elements, right? 1, 2, strings are also atomic, identifiers are atomic. So yeah, it checks. Is it an atomic expression? If so, what it's going to do is it's going to call the ASOC, which is associate. I'm not sure why they called it that, but yeah. It's essentially just going to look it up in the environment that I mentioned and resolve symbols, pretty much. So if the symbol is just the word add, it's going to be like, okay, what is add? What is that? Right, so there's going to be an environment that looks like this maybe, and here we have like the actual implementation of the add function. Then we also have a variable called n, which has value 6, and another variable called m, which has value 7, something like that. So ASOC is just going to go through this thing, finding this symbol. And actually the way that it's going to do it is it's going to check the first element of the list, which it calls the car. Car is the first element of the list. Not sure why they called it that. It's just the name of a register that the original machine that they wrote this for used, so it stuck around. Car is the first element of the list. It's going to check that, and it's going to check its first element, which is n in this case. Is it the symbol that we're looking for? No. Then move on, running ASOC again recursively, this time with the CDR, which is the rest of the list, ignoring the first element, the rest of the list. Right, so it's going to do the same thing again. Take the top of the list, take the first element of that. Is that add? No. Then run with the rest of the list. One more time. Is it add? Yes. So return this thing, which is going to be the implementation of the add function. So that's what eval does. That's how it resolves symbols. You don't need any fancy like symbol resolution. It doesn't matter if you have a 1-pass or 2-pass compiler, forward declarations, all of that stuff that you need to worry about with C is that simple in Lisp. Mind you, this is because it's an interpreted language also, not just because it's such a cool language, but it does help. But like I said, Lisp is the best interpreted language. You cannot debate me on this. Prove me wrong? You can't. You can't. Nobody's proven me wrong. See? Nobody was able to prove me wrong. There you go. Because you can't. You can't. It's the best interpreted language. And by the way, C is the best compiled language. Can't go wrong with those two. Can't go wrong with my hair constantly getting in my face. Right, so eval, that's the first thing it's going to check. If an expression is atomic, it's just going to resolve that if it's a symbol. Right? If it's a number or a string, there's no resolution to be done. It's just a value. Then it's going to check if it's not atomic, but it's something of this form. Then it's going to check the first value of it against quote and cond, which are two special forms of Lisp. Quote is just an escape. So if I do quote of this whole thing, instead of what did I do? How did I get there? I don't know what I'm doing today with the keyboard. I'm just messing everything up. Anyway, if I do quote of this thing, I'm essentially not going to be evaluating this expression. I'm just going to be returning it literally. So that's what it does. And cond is just checking conditions. So I am using it here in the actual Lisp code that I was showing. I like to think of it like a switch in the way that I structure it, but really in the way that it works internally is more of an if-else. This is the same as saying if n equal to 0, then return 0. Else if we want to be pedantic. You don't really need an else because you have a return, but again, just to be correct about this, if n equals 1, return also 0. and if else equals if n equals 2, then return 1, else return this entire thing, which is like fib n minus 1 plus fib n minus 2. That's the way that we're doing the Fibonacci sequence type of implementation, right? Here's the thing though. The function is recursive. Lisp uses a lot of recursion. And actually, eval is constantly calling apply, and once we look at apply, it's constantly calling eval, and there's a lot of recursion and back and forth between the two functions. Which is, by the way, also why I wrote, might not want to get this number higher than 10, it's not optimized. So it will get pretty slow if you try to run the Fibonacci sequence with a very high number. It's very unoptimized, it's kind of shit. I need to fix it a lot, I need to optimize it a lot. But as an initial implementation, it worked. Right, so it's going to check those two special forms, which have their own special logic to them. Quote doesn't evaluate the value. Cond will essentially check each of these conditions until one is true, and then it will return the CDR of this expression. So for each of these expressions, it's going to check the car, the first element, to see if it's true. And if it is, it's going to return the CDR, the rest of the elements, as the return type to this cond expression. By the way, the return is explicitly the last element of an expression. And also, this T here just means anything condition that always evaluates to true. T stands for true, and nil stands for false. Although in my Lisp, my dialect of Lisp, once I move away from Lisp 1.5 and I start making it into my own dialect, I might turn it into F also, just to make it TF. But I don't know, I haven't decided really what the actual Lisp dialect is gonna look like. Also, I prefer to think of it like a switch because you have, you know, condition, 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 case, default. So in the terms of like the way that the code is written, I like to think of it like a list, like a switch, but really it's more of an if-else statement. Right, so it's going to check those two, and if it's neither of those, it's going to call apply. Also, if the first element is not an atom, so in this case it is an atom, but in this case it isn't. It is actually a sub-expression. So in that case, it's just going to call apply on that. That's literally eval, incredibly simple function. Apply is equally simple, maybe even simpler. It's also going to check the function that you're trying to call, right? In my case, it was add 1, 2. 1, 2, 3, apparently. 123, I mean. So it's going to check the function itself. So because of the way that eval called this function, it actually looks like this. Fn is add, x is this thing, and then we have the environment again, which is, like I said, a linked list of symbols that have been defined. So it's going to check, is this atomic? It is. Checks it against these functions. Car, first element of the list, CDR, other elements of the list. Cons, takes two elements, forms a list with them. Atom, checks if something is atomic, essentially if it isn't an expression. EQ, equal, check for equivalency between two elements. So it has a bunch of built-in functions. I also have an add function. Add itself is a built-in function. Because it's actually like run by C code. And also any special behavior that I want my scripting to have will be put in here, pretty much. But yeah, it checks against these functions, any other built-in functions that you might have. And then if it doesn't find it, then it assumes that it is a function that is defined somewhere in the environment, right? So somewhere in your environment you have, like I said before, an add with its implementation here. And what it's going to do is it's going to eval this symbol alone. So not the entire thing, but just this symbol, which is going to trigger a lookup into the environment, and it's going to give us back this thing. So this is what it's going to look like. It's going to call that, and it's going to call apply on that this time. Now we're actually applying with something that isn't atomic. It's a sub-expression. And most likely it's going to be a lambda. So a sub-expression that looks like this. It doesn't make much sense to implement add as an actual Lisp expression. Like I said, it's actually compiled. It's run by C. It's a built-in function, but it doesn't matter. It might look like this. And that's when we get into these cases. Lambda, what it's going to do is it's going to take these arguments and these values, and it's going to associate them with each other. So pair list, it's going to pair them to each other. So in the environment, it's going to create new entries. An entry where A and 1 is going to be the first entry, and another entry with B and 23. It would have been a lot cooler if it was 2. B and 2 as another element of the environment. So it's going to modify the environment to have those two values in it. And then it is going to eval this thing, which is going to be the body of the actual lambda, right? And as it's evaluating this thing, it will eventually need to eval A and eval B, which will trigger a lookup, and it will find the values of the parameters that you passed into the lambda. So that's how function calling works. It's incredibly simple. A will look it up, will find 1. B will look it up, find 2. And then we can assume that the plus is a built-in function that knows how to resolve this thing, gives us the final result, which is 3. And that is going to be the result of the eval, which is going to be the result of the apply, which is going to be the result of its eval. Like I said, very recursive, but they always return the last expression, so floating all the way up, we get the 3 that's the result of the expression. The other thing that I have is label. So label allows me to give a name to a lambda, but it's not a function. When I first implemented it, I implemented it like a function definition, but that's not actually correct. It's more limited than that. It is a function definition, but it gets called immediately. So I have a label, which is this entire expression, and then I have a 6, which is the argument to the expression. Essentially what it's doing is it's giving this lambda a name, and also putting that name with that lambda inside of the environment, then evaluating the lambda with this 6 as its value, so that the lambda can refer to itself. Right, so I can use the word fib to refer to the function that I'm currently in, which is again how the function can do the same thing. Like n minus 1 plus fib n minus 2. To be fair, you don't really need to do this in C. But for example, once I actually have function definitions, which again, this is not a function definition because the fib symbol only exists within here. So if I try to do this, it will not work. By the way, I do hope this whole thing runs, because I haven't run it in like 2 weeks. It does. Okay, symbol not found fib, but you can see it actually gave me the result of the first one. This one actually worked, but this one gave me an error. So, that is the overview of the language. It is incredibly simple. You really just have to learn what S expressions are. And after that, very simple to code in Lisp. Now, modern Lisp has, first off, a lot of the things that I'm doing in the interpreter, I could have done in a more optimized way. Like, for example, the symbol lookup with the assoc function, which is again, the one that actually does the symbol resolution, right? If it's nil, return nil. Say symbol not found and return nil, right? Otherwise, check the first element. Is that the one that I'm looking for? return a copy of it actually. Otherwise, run assoc recursively with the rest of the environment, besides the one that we just evaluated. That is, in fact, a very slow way of doing things. The original way that I was planning on doing this was like with a stack of linked, not of linked lists, a stack of hash maps. So I can just look up in each of the hash maps, which is, as the scopes increase, a new hash map is added. So you look inside of them from the last one to the first one, which is the outermost scope, to the, well, the innermost scope to the outermost scope. Look for the symbol. With a hash map, it's a lot easier than going through each of the symbols, finding the exact one. It's hashed, so it's a lot simpler. Dictionary, lookup, a lot more optimized already. And yeah, just look it up like this. Can't find it in the innermost scope. Look at the one outside of it. Look at the one outside of it. But of course, that requires me to manage things a lot more manually. It won't keep the thing being 300 lines of code, but it would mean most likely I would be able to do numbers higher than 10. So that kind of thing. Other ways that things execute. Other optimizations that I could do in a lot of other places. That is probably the main one, in my opinion, the way that I do symbol lookup. I was going to do it like that with hash maps, but then I looked at how simple it is. And I was like, okay, I am implementing it like this. I'll optimize it when I need to optimize it, which is going to be very, very soon. Probably, yeah, one of these days I'm going to do that. But yeah, I wanted at least the first version to be truly Lisp like that. But I have to say, it is pretty cool how simple it is, how easy it is to wrap your head around it. How long was that entire explanation? Like 30 minutes? Based on the ad counter on Twitch? Something like 30 minutes. Alright. Another thing that Lisp is pretty cool with, macros, so meta programming, pretty cool, to the point that I actually want to use this Lisp interpreter inside of my compiler to do meta programming in other languages. I don't really need it right now, but I will be doing that. Because I think that's, Lisp is great for meta programming. It's also a very meta programmable language, which is the important part about it. Can Lisp 1.5 do macros? Honestly, couldn't tell you. I have no idea. I haven't actually used Lisp 1.5 besides the implementation that I did, and the reason I did that implementation is I got it from this blog, Program in Praxis, that they wrote in 2011. This is 15 years old, when John McCarthy, the creator of Lisp, died 15 years ago. On October 23rd, 2011, which is also 66 years before the bombs drop in Fallout. Spoiler alert for 2077, by the way. All right. So yeah, here you have the M expressions taken directly from the Lisp 1.5 programmer manual, which is, by the way, this whole thing here. It is an incredibly simple language. Granted, it being this simple does make it a little bit slow in some places that I will be optimizing, but it is an incredibly simple language. It is very, very powerful for scripting. And I'm going to be using that for my terminal, because what else am I going to use? Bash scripting? No. No. No, 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 no. Of course not. Actually, before I learned of Lisp, I was planning on making it a functional programming. Essentially to not do what Unix does with pipes, right? Because you can pipe programs with each other. Like, I can look up a specific thing by doing ls, which is one program, then piping the result of that into grep and looking up .c, and I get all my .c programs. That's not super accurate. Because I forgot, grep is actually a regular expression search. So I'm pretty sure it matched any character and then C. Do I have to escape it? Is that how it works, by the way? I have no idea. No, that's not how it works. Okay, actually, don't. But yeah, you can do this kind of thing, for example. Or not. What about anything that's two C's together? Nothing. What about... Do I have any repeated letters? M. Also doesn't work. Okay. So I don't understand the language of it. Oh, you need... Okay, you need... Thank you. Quotes. Okay, not like that. I'm assuming this one will work if I do it like this. What the hell? I can't get it to work. Nah, it's still the same. Anyway, grep is apparently regular expressions, but not in the syntax that I'm used to. So never mind. But the point of this is not grep. The point of this is I can take the output of one program, pipe it into another one, pipe it into another one. So my original idea for scripting in the terminal was going to be a functional programming language, where this kind of operation is very common. Take, one data, take it, pipe it into something else, pipe it into something else, pipe it into... So that kind of behavior is what I was going for. But Lisp came along, and if you want to make Lisp functional, you can make Lisp functional. If you don't want to make Lisp functional, you don't make Lisp functional. If you want to make Lisp declarative, you make Lisp declarative. Lisp, my beloved. Truly, truly a beautiful language. A beautiful language. Is it slow in the way that it works? Yeah. But it's such a simple, elegant, incredible language that you don't care. Anyway. And again, I was able to explain the entire internals of the language, missing a few things, in like 30 minutes. So it's that simple. Today I had the idea of creating my own OS. Nice. Welcome to the club. Can I ask where and when did you learn all this? Because I just finished my second year of CS and I don't know any of this, only some definitions. Honestly, feels like I wasted a lot of time. But I felt like that in college as well, to be honest. College is what you make of it. Let's put it like that. So it isn't necessarily that you're missing anything. Now, right now I'm talking about Lisp, right? Which is not a super popular programming language. It's not the kind of programming language that you're going to find like a ton of jobs for, if any. I'm curious. In Madrid? Oh my god. Okay, this is English speaking language. This is not Lisp though. This is just like a Ruby, Lisp, SQL, English speaking. This is just whatever lookup slop they came up with. Okay, there is some Lisp work, but anyway, Lisp like itself is not the most popular language. I literally learned it in like a month, by the way. In a month, I felt comfortable enough with Lisp to be able to make my own interpreter, which I made with Lisp code, except I had to translate it to C, but yeah. It's a very simple language. I really like that about it. But really, the way that I learned this stuff is just by doing it. How did I learn to make how operating systems work? By making one. Did I learn anything from the programming language, from the operating systems class that Mr. Tannenbaum taught me? Again, he just looks like my professor that taught operating systems. Just looks like a fair bit like him, especially in this picture. This guy has more hair, actually. But besides that, it very much looks like him. No, I learned way more from doing the thing than from my professor. No offense to him, he was chill. But still, it is what you make of it. But I feel like when it comes to programming, you learn by doing. That's how you learn programming. You get your hands dirty with it. And you learn by doing. The same advice does not apply to surgery. to medicine in general. Okay, so don't do that. I'm talking about programming. Doesn't work for everybody, but for programming, yeah, that's how I feel like it's the easiest way to learn. How do you learn the concepts? You know, there's a lot of like words that people use for concepts, for things that have names that I never learned the name, but I know what they're talking about. Like if you tell me the name of something, I'm like, but then you explain what it is, and I'm like, oh, okay, yeah, I just don't know what it's called because I didn't pay attention in college. So yeah, it's something that I learned by doing stuff and by experimenting, by having fun with it, and I feel like that's the best way to do it. She uses APL for the scripting. Isn't APL like? Oh no! I'm thinking of IPL, which is the information processing language, which is something that inspired Lisp. Now you're talking about APL, which let me look at it. Functional programming language for arrays. See, I was thinking of going functional, but the thing about Lisp is if you want to go functional, you go functional. If you don't want to go functional, you don't go functional. It's a great language. It's a great fucking language. But actually, the main thing that inspired me, that I forgot to mention, to make my terminal's scripting language Lisp, or my shell scripting language Lisp, is the fact that an expression like this in the terminal. What kind of? Say that I want to go into my documents folder, right? This is how I go into my documents folder. You know what it reminds me of a lot? Lisp! Granted, you got that. That's just fucking Lisp. Right? What if I want to compile something like GCC, then link against the current include the current directory and also include my library, redlib, and then compile what is it? Build.c, compiling my build system. Right, and here I want to link against this libc, and I want to link against libm, and I want to link against, I don't need to link against glfw, this is a terminal command. Oh, I think there's Jester incoming. You know what? It's Lisp, motherfucker. Get lisped. Get lisped. Get lisped, motherfucker. Now, in Lisp, you would do something like this, probably. What? Am I pressing the wrong key? I was pressing the wrong key. What the hell? You could do something like this, for example. Very similar. Very similar. Obviously, it's not exactly the same, but that is what like made me think of it. Like when I started, or I was under the impression when I started Lisp, let's put it that way, I was under the impression that expressions were always limited to just 3 elements. I don't know why I thought this, right? But a lot of expressions are like that. Like if I define a function in common Lisp, define a function, call it n, give it arguments, and then run, well, not 3 expressions, but like a limited number of expressions, right? And then the body of the function. I used to think that the body of the function would go like this. Inside of here, I write the expressions. Not sure what code this is supposed to be, but it's just to explain my point. Right? I thought this is how it was, where inside of these I'm not used to this setup. I'm moving my keyboard way too much to the right, and then it gets in my space of my mouse. Anyway, I thought inside of these parentheses, you put the body of your function, right? So it's define function, name of the function, arguments, inside of parentheses, and then body inside of parentheses. It's not like that. You can have multiple expressions like that. You don't need those parentheses. Actually, you can have those parentheses. That's what reminded me a lot of terminal scripting, because you just put arguments in the same way. Works very similar to that. Right. And I don't think I came up with the best examples for how it's similar to terminal. But yeah. Maybe you get the point, maybe you don't. I'm honestly not sure. But I think that is why I wanna that is why I love Lisp. That is why I love Lisp. And that's why I wanna use Lisp for scripting. What's changed in your setup? I switched my monitors around. So now I'm also sitting on this side, which does mean I cover this guy. But it does mean at least there's something to look at on the top part of this side of the camera. Still was nothing there. No, that was very annoying. Although I have to say I'm not loving this setup. Maybe tomorrow I'm gonna undo it. Because yeah, my laptop is covering important information on OBS. Then I'm also just not used to it. That doesn't help a whole lot. And I keep wanting to move myself to the center, but since I have my laptop here, I don't have enough space for the mouse and the keyboard in the center of the setup, whereas when I had my laptop on the left, I didn't have the same problem. I might undo the whole thing tomorrow. All right. Anyway, there's an ad break on Twitch right now, so I'm going to be back in 2 minutes. I'm trying to move to OBS. I was going the wrong way. I'll be back in 2 minutes. I'm gonna get some coffee, and then I'm gonna actually start implementing stuff. Okay, I changed my mind. I'm actually going to be doing scripting with APL. Thank you for that little code snippet. This is Quicksort. This is Quicksort. I had to go look it up because I couldn't have possibly told you. This is Quicksort. Using symbols, by the way, that my poor little ASCII only operating system cannot handle. Oh god, no. Although I did see the Now that I think, now that I see that code snippet, I did look at the game of life implemented in this, and it's pretty simple. It's just absolutely awful. Where did I leave my coffee? Okay. All right. Now I do like the changes I made to my desk, but it's uncomfortable. I like it better this way, but I'm not used to it. I don't know. Probably won't keep it. Pick 6 lottery. Okay, so they saw regex and they were like, let's make it worse, like even less understandable. Turing tar pit at first. What is a Turing tar pit? I mean, it looks very simple. Just like, what are those symbols? Come on, man. What is happening here? No. It's very mathematical. That's the part I don't like about it. It's mathematical symbols. That's really it. Right, I do remember I looked at it because I remember that one guy's last name is Breed and the other guy's name is Dick. That alone reminded me that I have in fact looked at it before. Can I link an article? Yeah, sure. Yeah, it's mathematical notation. My God. You see, back in the day before computer programmer was a thing, we had mathematicians that were the closest thing. So yeah, by the way, my cursor when I move over to this, because of course, my God, neither Wayland nor X11 can handle multiple displays properly with different DPIs. My cursor is tiny when it's on this screen. I'm literally considering at this point the best thing for me to do is to just get a better display instead of this old small DPI display and this 4K one. They just don't go well together. I love to babble about social issues of software development. I try to avoid mentioning them in technical discussions, also known as flame wars. So social issues. Today's social issue is the programmers adore Turing tar pits. Turing tar pits are addictive. You can render programmers completely paralyzed from a practical standpoint by showing them a tar pit and convincing them to jump into it. So by social issues, can I include, for example, the thing that I always rant about when it comes to software that developers use being not user-friendly, thus leading us to making more non-user-friendly software? Unless you're a JavaScript developer, which is why everything is JavaScript nowadays. Does that count as a social issue? Is that, am I using the word correctly? Is a Turing complete virtual machine that doesn't support straightforward implementation of bread and butter programmer stuff. So arithmetic, variables, loops, data structures. Brainfuck programming language. Yep. Isn't there a programming language that like for years, they didn't even know if the spec was actually like correct because it was impossible to implement. Not impossible to implement, but like ridiculously stupid to implement. It had, was it named after a cigarette? Why do I have that? Not Camel. I have I associate it with cigarettes for some reason. I don't know why. Was it called Marlboro or something? Raku? That doesn't sound familiar. There was one that like similar to Brainfuck, but even worse. Look at that symbol. Oh, this is about to be so diabolical. No, this looks normal. Come on. I'm being serious. There was a programming language that for the longest time they couldn't know that the spec was correct or not because nobody could implement it. Not that it was impossible, it's just nobody could implement it. Normal is Perl. I don't even want to look at Perl, to be honest. It's one of those languages that I'm like, I don't care. Thank you, though. Um, so yeah, the aliens are doing programming now. So AI was gonna take your job. You didn't consider the aliens. You didn't consider the xenomorph taking your fucking job. Like, what is this? You can really tell Perl was designed by a linguist? Hold on, let me look at Perl now. Because, like, I'm tired of languages designed by mathematicians. I remember looking at it recently because I found this exact code snippet in French. Um, which then led me to making a French programming language. Eclair is its name. There it is. Syntax highlighter is not set up for it, so it fails a little bit, but yeah. There's more than one way to do. Oh, that's wonderful. Yeah, no, that's amazing. All right, let me begin implementing some stuff then. Lisp. 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 How do we do this? Most likely, what I'm going to want to go ahead and do, to speak American for a bit, is... Sorry, what I'm going to want to go ahead and get started doing is making it so that this thing can be compiled into a library. Then including that library for shell scripting. And possibly, in terms of code base, the shell, the very basic version of the shell, is actually implemented inside of redlib, my standard library, but that cannot have any dependencies. So most likely, that means it is just going to implement a very basic interface for scripting. To which I will then attach Lisp scripting, which means technically you can do scripting in other languages as well. Same way that you can use different shells besides just mine by just adapting to the interface that I made for shells. Same thing happens with scripting. Right, because the shell.h, defines a shell handler, which has a buffer for output of the shell. Bindings, which are functions for what to do when the shell produces output, flushes the output, cleans itself, rings a bell, produces an ASCII command, or wants to control its parent, like closing the window, for example, when you do exit or Q. Then it has a context that is just environment, pretty much, current directory right now, but also environment variables will go in here. Local context, which is anything that the actual shell uses, and then an owner, which is who created the shell. This is the interface of a shell. Then the actual shell that I have uses one of those handles, and then also has, does it have a, yeah, it has this as its local context, the one that I said. It's just a void pointer. In my shell, it points to this, which just has built-in functions, a hash map of built-in functions. So most likely something similar is going to be happening for the scripting. Because I cannot directly include Lisp scripting into my library, I have to just create an interface for scripting, which is going to be very, very basic. Probably just a function pointer, mind you. Maybe even a binding. Maybe even a binding, actually, yeah. 100%. But it does mean if you want, instead of using Lisp, you want to make an interpreter for another shell scripting language, you can. Which, by the way, my terminal, which is actually just a text editor wearing a terminal costume, can technically execute commands within Linux. It cannot show their output simply because it is prepared to show output of programs in my system, which standard output of a program is file descriptor 2, or /proc, its ID, and then /out. Whereas in Linux it doesn't work like that, so it cannot read the output of it, but it can run the command. Run the command. So for example, I can run cat. Or not. Or not. That did not work. So yes, you can see it tried to open process 256 out, and it wasn't able to. To be clear, I've never looked at /proc in Linux. Can I look at my... How do I know the process ID of something? PS is the command for that. PS, EF, and then grep. See how I'm using pipes again? Do I use... No, we don't. The name of the process is redlib. And there we have it. It's this process over here. So I should be able to CD into these nuts. No, I can't. That sucks. 275. Oh, that's the wrong number, isn't it? It's this one, probably. Yeah. And here, what do I have? I'm not sure how I can read the output of the process. Whatever. I'll figure this out eventually. But yeah, it can run commands in Linux. It just cannot display their output because it's not set up to do that. It tries to access /proc/out. And by the way, it doesn't even have the process ID correctly. I probably did that a little bit wrong, and I'll have to make some changes. But it's not too much work to turn this into a terminal that actually works within Linux as well. And Mac. Windows, probably not, but who cares about Windows? Who's using Windows nowadays? Wait, by the way, I just remember somebody in chat accused me of using Windows a while ago. What was that about? I get it. KDE looks like Windows. You're not wrong in thinking that. Sometimes I look at people using KDE and I'm like, oh, they're on Oh, no, they're not. They're on KDE. I just remembered I read that before, but I didn't address it immediately, so. Just want you to know I did see you. I did judge you for that. Anyway, yeah, don't care too much about running commands on Linux right now. But it is a thing that I should be able to add soon. Alright, so what do I care about? Right. Evaluating an expression in my shell. What's the entry point for that? Come to think of it, what is the entry point? Um, okay, I actually hadn't thought of this. Like if I have a terminal script, right? Like for example, in my OS, I have run virt, which looks like this. It is just a bash script. Starts with bin bash over here. Is it just executed? I do remember one thing about it, which is that these symbols are used as a indicator to know what to use to execute it. The shell shells out. What does that mean? It spawns a subshell. Okay, that executes this thing. Okay, I guess the main question that I have is, can I run these types of expressions? Is that a thing that I can do? Can I run like this kind of thing in... Okay. 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 That answers my question and already tells me what is the entry point to doing scripting in the terminal. That's it. Okay. Got it. Got it. So this does make things a little bit more complicated for me. Because I still want to be able to write commands without the parentheses, and in normal shell script, no, not shell script, just like straight up writing a command. But okay, I know the entry point. Maybe I don't even need to modify the shell at all. Maybe, I don't know. Yeah, I probably don't need to modify the shell at all. Yeah, pretty much in the shell, I made a, not in the shell, in the text editor here. Sorry, this is not a text editor, this is a terminal now. This is a serious program. In your OS, it seems like you start up what's basically a terminal emulator instead of a shell at login. At login? But we don't really have a login as a concept, so... do you mean this? That appeared before the screen? Startup, I understand what you mean. No, that's literally just a console. It's non-interactive, but it is the same code base that was powering the first version of the terminal. We're now in version 3, keep up. We're in version 3, which is not a text editor. It is a terminal, totally. Not a text editor wearing a terminal costume. But yeah, the version 1 used to be the same code base as that, but non-interactive. It is like one of the first things I did on stream, by the way, is make the terminal. Off of that code base. Then I replaced it last month, and now I'm replacing that replacement with before it was even ready. Anyway, there should be a run. Wasn't it called run command? This. It's called command handler, right? Command handler. Right, so it's actually not in this file. That's the reason I couldn't find what I was looking for. Yeah, here. This run command is the one that actually runs the commands. Shocking, I know. But essentially, I want to be able to differentiate when I do something like this. That's projects, by the way. And versus when I do something like this, right? When I'm writing a proper script versus when I'm writing a simple command. And again, I hadn't even thought of the fact that you can write entire scripts in the terminal. You can technically just like backquote too, which allows you to do this. So obviously the obvious difference is, are there parentheses in the damn thing? Is there a parenthesis at the beginning? Is the first character a parenthesis? I'm not sure if I want that to be the criteria that I use to know between just run the command versus interpret the script. I don't know if that's how I want to do it. I mean, it might be. It might be. All right. It might be the easiest way for me to do it. Genuinely. Might just go for that. Yeah, just to move on. We're gonna do it like that. Also allowing the possibility of starting something with this. That's very long. Bin bash is so elegant. Bin bash is so incredibly elegant. You see, Emacs is an operating system, so this can be Emacs too. I am going to be honest with you. I've never agreed with Emacs as an operating system. I believe Emacs is a shell. According to the definition of shell, Webster Dictionary, no, actually, Wikipedia Encyclopedia defines shell as a projectile. Shelley Duvall. By the way, this is giving me ideas for new names for my shells. Because I already have Sheldon and Shelley after Mary Shelley. But there's also Shelley Duvall, Shelley Winters, Shel Silverstein. I don't know who this is. Computing, shell computing. According to Wikipedia, a shell is a relatively broad and direct access to the system on which it runs. It refers to how it is a relatively thin layer around the operating system. That is a closer definition to what Emacs does than a operating system. So to me, it makes a lot more sense to call Emacs a shell or a terminal than to call it an operating system. That's my opinion. At least that's the way that I see it. I don't really agree with people who call it an operating system, but I get where they're coming from. I agree with the sentiment, just not the word. I'm being pedantic. Can I do it like... like that, maybe. So if it starts with this signature, or it starts with a parenthesis, then we will consider this to be handled not by the shell directly, but by an interpreter. Although that technically means I'm making a different kind of shell, doesn't it? It's actually GNU / Emacs. Fuck off. Alright. I am just making a new shell, aren't I? At this point. I just kind of, again, want to be able to write commands in a simple manner like you do in a normal terminal, but then I also want to be able to, like this, And then I also want to be able to do scripting with Lisp. But that's technically two different shells, I guess. Because yeah, this is technically a subshell just of the imaginal kind, which is the name of the Lisp interpreter. All right, while I think about that a little bit, again, I do need to run my Lisp, or to compile my Lisp into a library. I need to compile it into a library. There's a famous scheme shell you could use, look for inspiration. That would be useful, yeah. What's the name of it? All right, pretty much just need this. Name, I am. Type. Well, no, the name is actually Imaginal. Imaginal. That's the full name of it. IAM is just to shorten it to /tools/IAM or /bin/IAM. The documentation is a journey. I'm scared of what you're saying there. But what's the name of that shell? Because I might want to look at how they do things, just definitely not how it works. So compiling all sources, ignoring output.c, which is output for the compiler to test the compiler, build.c, which is the old build system, main.c, which is not an amazing name, but the compiler's entry point, and rule parser.c. Well, you'll also need to yeah, that's good. That's actually that's good. So I don't need to make this so complicated. How about we do a couple macros. Def macro. X name for the executable name. Wait, I'm looking for something here. All right. So I want to define a parameter called islib. False by default. And then you can do if here. Yes, you can. If islib, then the name of the executable is going to be this. Well, not the executable is going to be this one. Otherwise, it's going to be this one. And then another macro for lib type or x type for the executable type. Same thing. This makes it a library. This makes it a binary executable. All right, so I plug that here and here. Ex name and ex type. And then depending if I make this lib or not, I get to compile this as either a program or as a library. All right, so it is lib, because we're trying to compile this as a library that we link against. So red build, and it fails. Hello, Ice Dave, how you doing? Did that open? Yes, it did. RDBSM. Wait, yeah, no, I need to find this scheme-based shell. Sksh. Is this the one? Sksh. Wait, no, that doesn't look like it. Is an open source Unix shell embedded within Scheme. Oh, it is that. It is Sksh. All right. This is the Sksh reference menu. But I really just want to see, if I just open the shell and run a command, can I do it normally without needing to write Lisp? Because it's going to be very annoying if I have to write parentheses for writing just one expression. Shell pipeline, yes, I know, but I definitely would prefer doing a pipeline like this than like this, 100%. That's why I'm doing this. But how do I write a simple function call? And also, how do you reconcile the fact that some programs will use arguments with like -l, -v, -help, helpo? Alright, anyway, islib is unbound. Parameter. Argument is not a symbol, imaginal. What are we complaining about? You know what? I forgot how to do if statements in Lisp. Do I have any here? Yeah, I have to do if eq first off. So that I'm doing wrong. What is this? Close that. So if eq this true, and then I'm just blanking on the correct syntax for doing this thing, but let me see how I did it here. You know what, I'm doing it with condition. Might be easier. Condition, where eq is lib true, then return imaginal, otherwise return cred. Alright, is that good? No, still no. I'm still gonna do it with condition. No, we're good, we're good, we're good. Should I just not make them macros and make them functions instead? Am I using if wrong? Oh my god. Oh my god. Parameters. I literally forgot to put parameters in a function definition or a macro definition. God, that was stupid. That was the entire problem. So I can make them macros, which is better because they're at compile time. Alright. And I told you islib is true, which should have created an imaginal.a. There we go. Okay. So I compiled my compiler, ironically, against as a library, which means now I can include it here. and link against it easily enough. Now, I can just include a new library to link against. That is a local lib called imaginal.a, located inside of the beyond directory. And if I'm not mistaken, I also need to define a name for it. A path, which is the root folder, and a name for it, which is imaginal. Okay, so that should be good. Now I should be including this whole directory into my compilation and including imaginal.a into my linking for my text editor. Right. So then I need to replicate. Oh, I'm including a main function, aren't I? Lisp.c contains a main function, which should not be here. But I think it's working fine. It is linking against that library, and it's not complaining about there being a main function inside the library, which I have to say is very weird. Wait. It's not complaining about it. I don't know what the problem, but there is no problem, it seems. I would have expected there would be a problem. Anyway. So the first thing we're going to want to check is if our command contains if is lisp. Right, and what we're going to do there is we are just going to check the beginning of the command. That's the first thing we're going to do. If no cmd.length, actually, if cmd.length is less than 3, then we already know it's not Lisp. Because at the very least, we need 1, 2, 3, and then more characters, or, you know, 2 parentheses and then something else inside of it. Otherwise, we know it's not a Lisp. So even though this whole thing is definitely going to be rewritten at some point with slightly better logic, we can check the length of the whole thing being written against 3, and if it fails, we know this is not a script. It's probably just a call to ls or something like that. Right, so do I have a slice start? No, I don't. Alright, so I'm going to check a subslice of cmd data with length 2 against this thing. And then this is horrible code, but it is supposed to be placeholder code. We know how placeholder code goes. stays for a really long time. But anyway, we're going to want to check for this. If we have this, we know it's a script. So how about we make it a script? And just return true. Otherwise, return false. How's that? How's that? Let's do that. All right. So if is script the command, then we will handle it as a script. Otherwise, handle v as a script. That's cmd. All right. Otherwise, we want to check if a substring. Well, actually, we can just check one character. If it opens a parenthesis, then return true. Right, and then we can consider that to be a script as well. Again, not the best way to know exactly, but doesn't really matter. I should be able to write something like this, which crashes. Hey! Doesn't crash anymore. Doesn't do anything anymore. Oh, there it is. It, I'm very surprised by this. It crashes before even getting in here. It also took forever to even get it to run. Oh, now it worked. That's concerning. That is concerning. Let me try again. Oh, it's... Oh, it was crashing because of this extra symbol that I had there. But there's no argument there. It was probably crashing while trying to resolve that. Yeah, but it gets stuck sometimes. I don't get why it happens. But yeah, it wants to handle this as a script because it is considered a script. But if, for example, I do ls, then it is not a script and it actually runs ls. Which, by the way, I realized this when I was checking ls earlier. By default, the home directory in my system, the shell's default directory is the home directory. In my system, that's home. On Linux, my system doesn't have users, so it's just home. But Linux has users, so it's actually this. It's your username. Which is why the default home directory is outside of the home directory. It also includes the lost and found. Oh well. Alright, so that seems to work well. And this is where I decide. Do I want to make it? Oh, I'm so not used to my camera looking like that. There's a whole empty space on the floor. You can see the floor. That's so weird. That's not right. Alright, that's better. You can't see the dog. Not that there's much to see, but still. Yo, you alive? Yeah, he moved his eyes, so he's alive. That's how I know. Alright, now I do need to decide. Let me look at the sksh. It's called that? Yeah, it's called the sksh. Like, what kind of name is SCSH? How do you pronounce that? Because like Bash is a great name, Bash, but this is sksh. He's stretching, by the way. They've shown me what it looks like to write complex pipelines. But I want to know, what if I just want to run a simple ls command? Does caveats. You know it's something great when it starts with... What just happened? What is happening? Oh my god. PDFs are full of wonders. Yeah, what the hell was that? God damn. That is one thing I never care about in my system is PDFs. Fucking hell, what the hell is that? So, a single dot is taking up all that space. Oh my god. Compare that to Emacs, where like... this is a character. And that means the character next to it is just that small with all this padding just to make space for it. And the character next to it looks like that. But that's so much simpler than whatever the fuck is going on in this PDF, where this is a character. Well, I can actually make the cursor match it, so at least we got that. And just do that. There we go. There we go. Currently reading one where text isn't selectable but code snippets are. That is incredible. Alright, anyway, it's not a great thing when you start with caveats. Doesn't look great when your shell manual starts with caveats. Maybe running... Okay, let me start with the caveats first. Designed for writing shell scripts, programming. It is not a very comfortable system for interactive command use. The current release lacks jog control, command line editing, a terse, convenient command syntax. Okay. That doesn't help me. Done. That is not convenient. Brutally honest. You know what? Actually, I'll give it to them. Great job. Starting by telling me what it isn't. It actually saved me a lot of time of having to look through this entire documentation only to find out that it doesn't do what I was trying to find out. It is not a very comfortable system. I'm starting to fear that this might happen. Because again, I want to be able to write a script, right? I want to be able to write an entire, like, shell script in my thing, and I don't have modifier keys here, so I can't even write parentheses. But I need to add that. And, you know, you got this. I write my thing here. I can write... It's weird to write it without parentheses. But then, how do I make a syntax where I can write both a command like this one? Let me do it in... It's very hard to do without modifiers. So I can do a command like this one. And then a command like... I don't know, val equal to 32, whatever. Then print 32-bit. Otherwise, print 64-bit. Right, how do I reconcile these two syntaxes? This is one syntax, this is a completely different syntax. So that makes it a little bit hard to do. The Lisp can live inside the parentheses. Yeah, that's the main way, I guess. Mm. It's not even the ambiguity, it's just like... Alright, how do I call ls from here, for example? It's not very comfortable to do this. And it's not amazing to do this. Though it isn't impossible. It is not impossible. Where eval could take these kinds of things and turn them into strings automatically for me. Make it even easier to work. But hey, you know what? This is okay for version 1. Maybe I'm able to do that. Okay, so I actually have a better idea. I want the shell to speak Lisp, but to translate this type of expression automatically into this type of expression, right? Except that's not really necessary. It's already doing that. It's already doing that. So it's not really necessary. I guess I can. Make dash slash a valid invariable name and bind all the files in the system as variables. That is not a bad idea. Again, I want to do it, but it's not a version 1 type of thing. Again, the Lisp that I'm working with, for that matter, doesn't even have function declarations. It has labels, doesn't have functions. It actually has the code for functions. Like I said, same reason that I implemented symbols in the environment in that unoptimized way that Lisp does it. I wanted to do exactly what they do. But I have this code snippet here that's going to be used for defining variables and symbols. Because actually, when I implemented label, I didn't exactly understand what it was, and I was confused by the way that it worked, so I just made it work like define should work, like defining a function. That's not how it should work. It should define a function that can call itself within itself, so make it recursive, but then immediately evaluate it once the function has been defined. That's the way that label works. I didn't know that's how it worked, and it only exists within the label itself. It doesn't exist outside of it. Define instead will modify the environment, not create a new environment with the label definition so that it only exists within the scope, but modify the environment, the existing environment, to create a new symbol there. Yeah. And then you can call the function from outside. So you will be able to do define function with your function and then call it from out here. All right. Okay. So I think I might, the best way for me to handle this will be to actually move the Lisp interpretation and the running commands separate from each other. Essentially, before it even gets to the shell, the text editor finds the command, notices that it has this parenthesis or this, and it's like, this needs to be interpreted by a subshell. So kind of like we just found out Bash does it. It creates a subshell that interprets the command. So it does that, but instead of it being a subshell, it is considered to be a Lisp interpreter. And then whenever you actually call a command, because again, you should be able to do something like this in the script that you're trying to write, then it will defer it to the actual shell to run that command. Maybe I won't like the way I'm building, but at least I'm building it. I'm just gonna do that. Alright, there is an ad break starting, which I just realized. That means this has been an hour of just planning how this works. But I don't have any more coffee. Actually, I do have a little bit more coffee. But I have it here. So I don't have to get up. So I'm not gonna take a break. I'm just gonna write a little bit of boilerplate for a REPL, which stands for read eval print loop, which is just gonna be the main part of the interpreter that takes each expression, evaluates it, prints, goes to the next one, so on. Which is technically what this lisp.c inside of the compiler is doing. The problem is that this one works off of a... First off, why do you create a buffer? Yeah, it's interpreting a file. Ah, right. Yeah, so this kind of behavior here, for parsing arguments, that's not really necessary. We want this part, which is going to take raw text and turn it into Lisp. This part. No, you're going to return a code gen of parse Lisp based off of a buffer called buff. There is a buffer called buff, so we're not going to use that name. Code, let's call it code. Alright, based off a code buffer, you're going to be returning an empty code gen, which I'm pretty sure I actually called a nil expression. Can you use that? No, that's not usable inside here. Alright, and you're going to return the actual Lisp code without interpreting it, just returning it. And then, I don't know why this is here. But yeah, new lines are not parsable in this tokenizer. Now the tokenizer will need to be rewritten, but it does allow different kinds of comments. I can choose between the C-style comments or this type of comment. I haven't added support for this type of comment, so I haven't done that because I want to rewrite the entire thing. So anyway, that's our parse Lisp. This is the actual interpreting of Lisp. And this is the printing. And then we can loop it. Right, so you just do parse Lisp with what code? Buff. That is going to create an IR. If no IR.type or no ir dot pointer return -1. That was an error. We're gonna propagate it, and that's it. But this is the code that we care about. So this is the code that we care about. And again, I can't really put it inside of the shell. So I'm gonna put it here. If it is a script, we're going to handle it as a script. Ooh. Including... wait. REPL.h codegen parse lisp with a buffer code. Because that actually needs to be implemented there in the REPL.c, which is going to include the REPL.h, and the REPL.h is going to need to include irgen, and it's going to need to include files buffer to fix those compilation errors. What are you complaining about? Is it general? No. You need just codegen, right? It's irgen. Oh, it's codegen. That's what I want to import. Codegen. Which codegen is not the most accurate name, but because this also powers the compiler's metaprogramming, which doesn't have, but it will power the compiler's metaprogramming. It is IR. It is bytecode for the machine, essentially. Alright, so we also need to include data format tokenizer, as well as data format helpers token stream and the compiler's parser. That it? No, also the IR for Lisp, which is IR lisp.h. Alright, that's all the includes. But now we have the REPL all put here. I can just call this function to parse Lisp specifically. And now I can just include imaginal. Is it interpreter? Interpreter REPL.h. This is not the right place to write this code, but it doesn't really matter. Alright, buffer, no, slice from buffer. Oh, that's the other way around. No, that's wrong. A buffer is technically not modifiable. So wait. This is technically not modifiable, so I'm gonna turn into a string slice, which just makes a lot more sense to think of the code in terms of string slice. That's it. Now I can do just a string slice. You will parse Lisp from that. If that fails, you will just return, and not a -1, just return. You're not going to print debug, we don't need that. And then you're going to perform transformations, which is missing I want this to be a single file import, so even if it's not included, you are going to include it here. No? Where's perform transformations? archtransformer.h. That's what I need to import. All right, so now, good. And that is going to evaluate our code, which I should be able to print. Imaginal print, that's also missing. So also finally include imaginal.h. So you can now do imaginal print of the modified IR. No, not GDB. Undefined reference to parse lisp and to perform transformation. Oh, right, because I haven't actually compiled them. Implicit declaration of parse lisp. Wait, I actually haven't imported the REPL file here. So now I actually don't need to import these or these. And common is not being used for anything. Right. And here I also need to do slice from buffer to transform it into a read-only slice. Not that it changes anything. There's no such thing as read-only here, but whatever. And we still have no reference to perform transformations. What? 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 Why? It's just a call to this, but I don't see why you don't have it. How are you calling that? I know it's a linking error. I just don't understand. The thing is that perform transformations can be implemented in two different ways, right? Because the compiler can compile 3 different languages right now, and they do have a little bit of like different behavior. So this function is behind conditional compilation. So I understand what's wrong. What I don't understand is how is it able to compile, or how was it able to compile before, but not now? I haven't really removed any files, have I? From the list of possibly compilable ones. It should be in the imaginal.a. Oh, because now I need to manually pass these in, don't I? Not really. Not really. I can handle it. Can I do if and def with 2 variables? Because I need to make sure that both of them are not declared. two values. I can just do it twice, but can I just put a... like this? Is there a way for me to do this, is the question. If defined, if defined. That's ugly. Oh, well. I guess that'll do. That's the other one that I also need to check. That's in the rule transformer. So here, rule transform. Invert these two conditions. And put an end if. Looks ugly. There's a separate def macro? What? Surprisingly, this only got one response, by the way, which is very weird. When is this from? Is it after 2023? No, 9 years ago. Very weird. I would have expected a lot of people to have some opinions about doing this type of thing. If-def and if-end-def are just syntactic sugar. You know, I did not know that. You don't think of the C preprocessor as having syntactic sugar. It's more like syntactic pepper. It's not exactly the best thing out there, but whatever. I do need to manually recompile. Boom. And now, boom. 3. We have scripting. Lord in heaven, we have scripting. Goodness gracious, we have scripting in the terminal. Look how easy that was. Isn't it amazing when ridiculous bugs don't get in your way? By the way, yesterday there was a really ridiculous bug where modifier keys just randomly stopped working in my terminal. Not in my, yeah, in my terminal / text editor. Halfway through development in yesterday's stream. And I have to be honest, I don't fully understand the logic of what they broke. Why they broke only in that moment. They should have broken earlier, I feel like. I understand what happened and I fixed them. They do work now. I just don't understand what broke them in the moment. So if def is actually just if defined and if not defined. Interesting. You know, I found out something, another kind of interesting thing. I found out that size of, you can tell size of is not a function because it gets highlighted to yellow. Here's the thing, you know what else gets highlighted to yellow? Return. You know what that means? If I'm not mistaken, you can do this. Found out that recently. I did not know that. In the slightest. Did not know that. It also means, technically, that size of does not really need a parenthesis. Or does it? Apparently it does. It does. Thought it didn't, but it does. Not sure why. Shouldn't I be able to do size of without parentheses? That's the entire point of what I was trying to say. What is the error exactly? Expected expression before source file type. Maybe there's something else I need? Geeks for Geeks, by the way, I've heard this website get a lot of hatred. Don't. Alright, this website is great. No, I don't think sizeof is an operator that uses parentheses. That doesn't use parentheses. I don't know, that's very weird. There might just be some parsing ambiguity sometimes. Yeah, it's fair. I can't think of a single place where I'm using size of that I should be allowed to do that. Maybe if I do it like this. No, it still complains. What if I do this? No. Expected parentheses around the type name and size of expression. Type name. Alright. Well, you can have return with parentheses. Since it's a very final expression, you kind of don't need them. It's kind of ridiculous, but you can have that. It always requires parentheses when used with a type. When would you not use it with a type? The size of an expressions type. What does that? So how can I... By the way, this warning in Clang is some of the stupidest fucking things. Suspicious usage of... I don't mind being warned of these things because it's very likely that what I meant here is not size of, but just the value too. I didn't really mean anything. I'm just trying to use size of without a parenthesis, right? Which you can apparently. But the problem is that you're gonna be warning me every time. And I need to do something extra to silence it. That's very annoying. You can do size of x, where x is of type t, and it's the equivalent of type t. I see. So if I have size of buff context, not size steady, size... okay, there we go. Suspicious usage. Why would you call it suspicious usage? See, that's what really annoying, because I know what I'm doing. Kinda. You literally just learn how to do this. It is happening with a variable too. Like, it's very weird. What about if I do file type ID? Oh, now it doesn't. Now it doesn't anymore. Okay. It happened when I use a pointer. Interesting. All the, like, ground coffees on the bottom of this thing. It's gross. Assuming I probably meant to reference it. That makes sense, yeah. So that would have given me the size of a pointer. Interesting. Okay. So you can use size of without parentheses, but most useful cases you need it with parentheses. Okay. Cool. But yeah, I learned that recently. I learned about... well, I knew about if-def. Actually, did I have one of those if-defs before? Well, there's this one. I don't remember writing these. I would have thought I wrote them as... Oh, yeah, actually, elif-def is not a thing as far as I know, so I wrote elif defined. But yeah, okay, I got what I wanted. And I got scripting working. Array sizes, yeah, that's... I'm using it for that in a few places. NR in my... here. So I could do this, apparently. Even though it helps reduce the ambiguity. See, parentheses are useful, they're not just for Lisp. They reduce ambiguity. Alright, you know what? I'm bored. So I'm going to implement rebuilding projects like I did for make projects. Rebuilding dependencies that use this same build system. Parentheses are good for readability. Actually, like, one great thing about they like their precedence implicit. I feel like C programmers could probably hate if instead of doing this, you have to do this. Yeah, I understand how it can be a little annoying. I also forgot to put a plus here. I understand how it can be a little annoying, but when you're doing something like this, what is the precedence of this? Which one of these goes first? Depends on the compiler. Probably most compilers implement it properly, but do I know at a glance what the order of operations is here? Not really. Whereas in the other one, I do know at a glance what the order of operations is. You have innermost, then outermost. Related grats in the scripting, thank you. Technically not doing anything useful yet, but it is there. We have if statements already, well, conditionals. We don't have functions, but you don't use that functions that much in terminal scripting. Although, yeah, you could, but you don't use that all that much. There is one thing that I still need to resolve, and it's how to call programs from within the Lisp. Right, because the way that I do it in Common Lisp is it uses a library, but this is for terminal scripting, so it should feel more native, even if, again, version 1 is going to look like this. I don't care if it looks like this. This is just for the script in itself. I am making an exception. When you're not using this, I directly skip the interpreting part, and I go straight to running the command. However, when you do use parentheses, or you use this, I know it's a script, and I interpret it as such. Interesting that the, what is it called? The syntax highlighter is considering this like a comment. Like it automatically gets rid of that. By the way, I just thought of I've heard of people actually writing commands that they can execute from within Bash that are internally Lisp. And I don't remember the name of that or how it works or who said anything about that. And I believe I am not subscribed to a YouTube channel that I've been watching a fair bit to learn about Lisp and Emacs. I am not subscribed to that guy. I'm pretty sure he was talking about it. Essentially that you can have a bash script, but that internally actually runs Lisp, a Lisp interpreter. So you can write Lisp inside of that script. Which, A, would be very useful for my build system, because you need to download a bunch of dependencies for it, which is not great right now. And B, nice to look into to how they're doing, you know, combining Bash and Lisp, I guess. APL are very protective of their code size, so why would you put characters in the code that can be statically inferred? Yeah, okay, their code does not look very readable. So if they're able to read it, I'm sure they know about precedence. Again, that's a language for mathematicians. I have to say, I could have come so close to not liking Lisp because it was created by a mathematician. And again, back in the 1950s, most computer programmers were mathematicians because, like, there were no computer programmers. Like, 10 years before. So of course it's people who do mathematics. It makes sense. But God, did we get some shit from that? Like that was awful. Even when I was reading about regular expressions, and they were using like epsilon, was it? Something like that. Some mathematical expressions. I was like, bro, no, don't do this. Don't do this. Hello, Best Creeper. How you doing? Willkommen. Alright. Don't talk shit about my goat, Ken Iverson. Who's Ken Iverson? Kenneth Iverson. I'm assuming British. Oh, developer of APL. Yeah, that's a mathematician, alright. Yo, we have the same birthday. Few years apart. I was not born 1920. But we have the same birthday. Like a couple years apart, I believe. Not too much. But yeah, computer programmers back then were mathematicians. So a lot of these computer languages were mathematical. Like even like stuff like lambda notation. Lambda calculus, actually. Not lambda notation. Lambda calculus. It's how lambdas work in programming languages nowadays. Lisp uses them a lot. I was just explaining how Lisp does lambdas. Other languages use lambdas as well and whatnot, but it's literally a mathematical thing. They're literally a mathematical term. Was it brought into programming by Lisp, or I'm actually not sure. No, well, it was technically introduced by mathematician. See, mathematician. But then didn't have anything to do with computers directly. No. Its relation to programming language was clarified in the 1960s. The lambda calculus was only a formalism, thanks to Richard Montague. Montague, I'm assuming, and other linguist applications in the semantics of natural language. Lambda calculus has begun to enjoy a respectable place in both linguistics and computer science. It is true that all programming languages are mathematical, but some are more mathematical than others. In the philosophy that they use, mathematical notation. Like, you cannot tell me that APL, the fucking xenomorph programming language APL, and C are equally mathematical languages. You cannot tell me that this and C are equally mathematical. Come on. This is what E.T. was programming with. This is what the Disclosure Day alien said at the end of the fucking movie. Like, no. True, everything is mathematical, but like, no. The main feature of APL is that everything is a possibly multi-dimensional array. Well, same for Lisp, except it's a list. But it's kind of an array. I'm more fighting against QEMU than my OS now. Well, that's very nice. Default change depending on the VM. That's beautiful, actually. Oh, by the way, another thing that I haven't implemented for Lisp, which is probably going to be very useful, is garbage collecting. I have like a vague understanding of how to do garbage collection. But, you know, not entirely sure how to do it. I'll need to research it a little bit before we do that. So for the time being, it's just gonna be a language full of garbage. But hey, I can do 1 plus 2. Wait, hold on. I can also do 1 plus 1. Hold on. Watch it crash. Whoa! Look at that. It's 2. Whoa! Incredible. Incredible. Um, Alright, so I also want to get rid of these. There's a thing in my OS's terminal that I'm going to port over to the text editor as quickly as possible. And that is the debug print. It's literally just another function for printing, literally copied off of the print function, just doesn't wire into the console. Because when the print goes through the console, then you end up with this stuff also being printed, as it was here a minute ago. I already closed it. But besides getting the result to the operation, I also got a bunch of other crap that I didn't ask for. So we don't want that. So we're just gonna make a debug print.h, and should be good making this like pragma once, then include types.h. No, not types.h. VA. How are VA list defined? I have my own definition of it, which is just a built-in from a compiler, but args.h. Alright, including memory and including ring. And of course including syscalls, which I'm pretty sure it's enough to get rid of most of that crap except for the memory. Yeah. Alright, so make this also static. Inline, what the hell? I always tag everything as static, also as inline, even though it's not gonna get inlined, but whatever. if it does it, it's technically a tiny little performance boost. Technically. Anyway, now I should be able to put those prints here and not actually have them show up in the terminal. If I just use debug print instead of print. And maybe I include the thing that I just did. Yeah. So now it keeps my console actually clean. Because when you're working on the console, and especially when you use print debugging instead of GDB, which is an utterly useless piece of fucking shit, then, you know, printing will print to the console, which will often mess up what you're doing, besides also making it dirty. So, yeah, convenient to have a function like that. Writing a simple garbage collector in C, very useful. I'm not doing this today, but all right. So allocator with a free list sounds good. Mark and sweep. Okay, so I have heard of mark and sweep. I know mark. I'm not familiar with sweep. We haven't met yet. Stop the world, naive, mark, and sweep. Even cyclical references get freed eventually. Nice, because actually my buffers for the text editor and shell have cyclical references to each other. But we don't have a garbage collector, so it doesn't matter. And also the garbage collector is for Lisp, not for that, so it doesn't really matter. In order to ensure we only use the two... No, hold on. Scan a region of memory and mark any items in the used list appropriately. Both arguments should be word aligned. From beginning to end, scan, get the pointer at the location. What's happening here? Where's this coming from? Used P? I think I have to read the entire article. I was trying to get a very quick overview of it. Maybe Wikipedia has a very quick overview just so we understand what we're looking at. But I'm not implementing it today. But I will need it. Each object in memory has a flag reserved for garbage collection use only. I actually have, I believe, 64 or 32 bits empty in my allocator. That was probably leaving behind for something like this. I need to check how much, but yeah. At least 32. Maybe 16? I don't know. This flag is always cleared except during the collection cycle. The first stage is the mark stage, which does a tree traversal of the entire root set and marks each object that is pointed to by a root as being in use. Okay, so I have an object that is the root of what is being used. I go down it, and every time I find an object, I go to that object and I mark it as used. Then anything that is not marked as used gets freed, and then everything gets marked back as 0. The flag gets cleared every time. Is that how it works? If not, that's how it should work. I'm assuming that's how it works. All objects that those objects point to and so on are marked as well, so that every object that is reachable via the root set is marked. In the second stage, the sweep stage, all memory is scanned from start to finish, examining all free or used blocks. Those not marked as being in used are not reachable by any roots, and their memory is freed. It is how it works. You can have multiple roots, figured as much, yeah. Which we probably will have, considering this is a REPL type of system. Speaking of which, alright. It is time then that I consider how to reconcile my scripting, because again, I have scripting, but it can only run built-in functions to Lisp. Whereas I want it to rely on being able to do other things. Essentially, my plan is, let's look at my apply function, which is the one that actually runs a function. I was explaining the way that it works before, so I'm not going over it again. But Lisp's apply function, which just to show the code, I'm going to use this one, is going to check these built-in functions. Char, the first element of a list, CDR, next of the list, which are the functions that get the first element and function that get the rest of the list, const that constructs a list out of 2 elements, atom that checks if something is atomic, essentially not an expression but just a single item, EQ, which checks for equivalency. I have those implemented, as well as add, sub, mul, and div, which are my mathematical operations that are built in to the imaginal Lisp itself. However, here we have any function that doesn't match any of the built-in ones. What do we do in that case? Well, we're going to take the name of the function, the actual word of the function. Let's say that the function that we're running is fib, the Fibonacci one that I was showing before. We're going to take that alone, just that, and we're going to evaluate this. And as I showed in eval, when you have an atom that's being evaluated, you're going to check it against the environment, against the symbols that you have defined, and you're going to see, is it here? If so, you run it. But what if it isn't? Like, for example, if instead of fib, which is a symbol that is defined in the environment, I am doing ls. What if I'm doing ls? Then this is a symbol that is not defined within Lisp and is instead going to be run as a fallback by the shell. This is how I plan on powering the commands. So essentially, that means we're going to try to resolve the expression. We're going to try to resolve the expression, and if we can't, then we are going to defer that to someone else. Yeah, we're going to defer that to someone else to evaluate the expression. So if the expression is nil, then here we're going to defer this function someone else. And this is what allows us to hook commands into the scripting language. This is how I'm going to be able to run things like ls, which is a program, because essentially will be deferred to it. To do that, we're going to have an, let's say, extern function pointer, which has a boolean, indicating whether it was able to return or not. Now, this will have kind of a limitation in that it's not capable of returning wait. Maybe I want to return an integer, a U64. Yeah, let's make it return a U64, which is a pretty versatile return type. Although it may just be used as a boolean, I don't know. But I'm returning 64 bits, so that's what matters. The actual value of it may depend. Of a function pointer called fallback, imaginal fallback fn call, which is going to work as a separate version of apply, like that. And I'm thinking of how to structure this, but anyway, let me just write the code first. If we have an imaginal fallback function call, then we're going to check that. We're going to... Actually, you know what? Return a code gen. Fuck it. Return a Lisp expression through it. So you're going to return that. Return the function call using this, the arguments, and the environment as they are. Otherwise, return a nil expression because the function was not found. Right, the symbol was not found, which eval will already give us an error for. All right. Now I'm thinking, at some point, using function pointers, I created something of an optional function. And I don't remember where I did that. But essentially, there is a function pointer that you can assign to. and, you know, just give it about pretty much, yeah, just make this not extern. Yeah, that's actually enough. Just make this not an external one. Then in the REPL, we can put it as an extern one so that other programs can see it. And now, going back to my shell source over here, before you do this whole thing, the imaginal fallback function call, we're going to make it a void shell imaginal func call. Not a void, a code gen. The expression, the arguments, and the environment. We will assign it to that. And if we don't assign it, then this whole behavior just doesn't happen. All right. I'm also gonna just take this whole thing and REPL run bool print, create a function like that. Where it has this inside of it. Oh, and maybe string slice code. Debug print is not our thing. That was not supposed to make it into this. Here we return false. Here we return true. And we only print if we're being told to print, which is going to be p. Because there's a function called print. All right, so it looks like that now. Simplifies the code that I have to write a lot. REPL run using the command and do print. Maybe I can actually make it return a code gen. Fuck it. Returning a nil expression. Which, by the way, I'm very surprised that nil expression is a macro, I believe, that I only defined inside of the .c and not the .h. It's a very useful macro. Nil expression, return IR. All right, so that is going to run the REPL just one time, pretty much. I can optimize it so that the scanner and the tokenizer are always the same, but that doesn't really matter. They're actually not even allocated, if I'm not mistaken. Oh, maybe this one is? No, it's not allocated. They're not allocated, so we're good. We're good. We can recreate them every time. Stony, how you doing? Hello. Jesus, it's hot in here. We're scripting. We're scripting Lisp in the terminal. It's doing very good, very happy. That's how I'm doing. Don't even give me time to respond. Yeah. All right. So that just cleaned up the code a little bit, but we have our imaginal func call and print fallback and return a nil expression for the time being. Which, let's see now. Right. Okay. I forgot. I said I was gonna do dependency rebuilding, so I'm gonna make red build build dep beyond. And for that matter, I'm going to do the same thing for uno. So I can build my dependencies. I'm going to go into the build system real quick. And this is what I love about Lisp. It's so simple and quick to do everything. Where's the dog at? Oh, I moved my setup, so... He's headless, but he's there. He lost his head. Alright, I called it... build depth. And look how quick this is going to be. He's not passed out, he was actually looking at me. He just looks passed out. Def macro, build depth, taking a path. Lisp actually makes you so quick of a programmer. Way more than vibecoding ever could.
Gaenoob readied your channel with 3 viewers.
That is the cool thing about interpreted languages again. We are going to run... I'm hoping this happens inside of a subshell. Wait, I might need to take something from somewhere else. Yo, what's up, Infinite? Welcome. And hello, raiders from Gaenoob. How you doing? Hello. I am not wearing my headphones these days because it's super, super hot. Also, the padding thingy is falling apart. So, I did not hear there was a raid. Alright. I do wonder, can I just do this? Or is that too much? Is that too much laziness? Because I did create something that actually like but no, takes you inside of a directory inside of the current directory. This is instead taking you to a new directory. Although I should probably develop that, but it's worth seeing. I don't know what you're doing, but we're gonna stop you. Awesome time to learn Lisp. It is. It is. Mind you, we haven't even designed the Lisp language. This is Lisp 1.5. Well, no, this is Common Lisp. The Lisp that I'm scripting with is Lisp 1.5. Way back in. Do I still have the manual open, by the way? Also, very mathematical notation here with the M expressions. Nowhere near as bad as freaking APL, but yeah. Don't have a date on this one? 15th printing 1985, so it was already pretty old by 1985. You can tell how old this is. Lisp came out in 58. So Lisp 1.5 probably didn't come out super late. The research reported in this document was made possible in part by support extended in the Massachusetts Institute of Technology Research Laboratory of Electronics, jointly by the U.S. Army, the U.S. Navy, the U.S. Air Force, under contract blah 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 of the Department of the Army Task, and in part contract blah blah blah. Additional support was received from the National Science Foundation and National Institute of Health. Reproduction in whole or in part is permitted for